Hi, my name is Adam Chandler, and I'm going to walk you through some setup and getting some lighting into your white box. So up to this point, hopefully you have a basic space to move around in, some amalgamation of shapes, then the player can move through. So if I hit play, you can move through this space. So before we bother with putting in a lot of decoration, we still want to keep everything white and pretty plain, but we do want to get a sense of how the lighting's going to work, because we can use that to pull or push the player certain directions. So maybe we have a big shadow over here with a big spotlight in the middle that could pull them that direction, and that might be important for playtesting. And this is before we've even put any assets in. So what I want to do, I want to talk you through a basic lighting setup, kind of some concepts and principles, and then some check boxes that I recommend to start off with. And then after that, I'll make a separate video that walks you through step by step on, as you're putting things into the scene, what to watch out for. So first off, I recommend, if you're able to do it and you have a somewhat decent machine, turning on this auto generate, which is in the lighting settings. If you don't see this window over here, this is kind of what I like to do. I like to go to Window, General, where is this? Rendering, Light Settings, Lighting Settings. You click this. I like to dock this window over here next to my inspector. So once you go inside this window, you'll see down at the very bottom something called auto generate. And this is super handy because it will bake the lighting in the background as we work, which is pretty neat. But it will hog your machine a little bit, but it tries to give you enough that you can keep working. Some of you may decide not to do this and just to turn it off and say, I want to be really efficient while I'm working, and I just want to generate lighting overnight. That's fine. Just know that it does take a long time to do, and you never want to bank on that being completed by a certain time. So however you want to work is fine. I prefer to work with auto generate on. The second thing that I want to talk about is just in general the concept of baked lights versus real-time lights. Older practices and some current practices as well will have light baking, where you'll have a light over here and you will bake the lighting information onto all the geometry around it. And this is pretty handy because it's very performant and efficient, but it may not be handy if you have something like a player who can move around the scene. You can't really bake lighting onto objects that can move around. It goes against the principle of that. So I'm going to show you a setup that's going to utilize a lot of real-time and mix lights, and we're going to use something called a deferred rendering. Default inside of Unity is forward, which is very performant and optimized. It will let you combine bake lights with real-time lights, and the real-time lights will be fairly expensive. It's one way to do things. Deferred it requires more resources from your machine, but you don't have to worry about a lot of the intricacies and details and dealing with all, fixing little light maps and what's baked and what's not. So I'm going to show you the deferred setup. Just know that you can find lots of tutorials on the internet for how to do the standard baked and real-time setup. And one more principle before we get started. I do want to tell you at least tell you the difference between these. A general light will either be baked, mixed, or real-time. Baked is what would work with the forward rendering setup. Baked will just bake the lighting information on it. You can do that before you even hit the play button. When you hit the play button, it should look the same. However, it will not light real-time objects or dynamic objects that move around. Mixed will give you it's kind of like saying stationary. It's like a light that does not move, but can light movable objects. So this player, you could imagine if we had a campfire here and we wanted to move around the campfire, we would want that campfire to cast a shadow outwards, and we would want to see that change as the player is moving around it. With a mixed light, that's significantly more performant and optimized, and we can do that. And because the light doesn't move, it's better optimized. So that's a mixed light. And then a real-time light is just a dynamic light. It will light everything, every frame, it will constantly recalculate. It's pretty intensive, especially for a forward rendering setup. So you don't want to have too many of these in general. However, I mentioned forward rendering and deferred rendering. The difference is forward is the current default and whatever. You deal with baked and mixed lighting and real time. Deferred allows us to use more real-time lights at a cost up front. But if we add lots of real-time lights, each particular light we add is very, very, very little overhead. So we're paying the cost up front. Forward rendering is where we're paying very little upfront, but every new real-time light we add adds significant overhead. So in general, if you have lots of real-time lights, deferred's definitely going to be the way to go. If you only have a couple, you might consider forward. Just know that it's a lot more complicated to set up, and you can run it on more optimized machines and so forth. But I highly recommend just trying to get a beefy machine and doing the deferred rendering setup. Okay, the last thing before I go into how to apply all this stuff, I did want to show you one little thing called pixel light count. I see a lot of people having issues with this, and all it is, so what happens with the pixel light count is if I were to make a few lights, let's just make a new light, point light. Oh, that's way far away. And I were to duplicate a couple of these, and you'll see that a light is defaulted to real time. So you're already starting to see what's happening. As I duplicate more of these around, you see how some will kind of disappear and reappear sometimes, right? So what happens by default is Unity can only render a certain number of real-time lights at a time. So it will keep a few, but any more than a couple, it will just not render. And what this is actually doing underneath the hood is, if we go to, let me see, I think it's Edit, Project Settings, Project Settings, Count, Quality. Yeah, Quality. You'll see for each quality level in our quality settings, if you click on one of these, and this is what you get to choose whenever you initially run the executable of Unity. If you click on each one of these, it will tell you how many pixel light counts you're specified. You'll see the even Ultra with the standard forward rendering will only support 4 real-time lights at touching things at a time. So even at the highest setting, and again, this is the drop down when you double click the executable, and you can define that per one. So what I'm going to do is I'm just going to crank this up to 10, because I'm probably not even going to use this, but I at least want it to be consistent if I do. And I'm just going to delete these out. So that's the pixel light count. You could think of that as the number of real-time lights we can render at a time in the forward rendering setup. So with that out of the way, one last thing I want to mention before I keep saying last thing. Avoid gigantic pieces of geometry. Like, let's say I had a plane that was like this, and I tried to bake lighting on it. It will take a very, very, very long time to bake. So all these gigantic pieces, these background pieces and whatnot. In general, if you can, it's better to break out your really, really large pieces into little chunks, kind of like this. And if you can, well, I say kind of like that because I'm not really snapping it together properly. But if I were really doing that properly, yeah, like this. And then you would want to do it that way so that each little piece can bake individually. Otherwise, you're just going to get hung up on this one gigantic piece. And so just watch out for that if you have huge pieces of geometry in the background. Try and break up things when you can. Okay, so I'm gonna pause it right here, and then I'm gonna start a new video where I walk through step by step what to do as we implement a lighting setup in our level.